Well, thank you, Reza. I greatly appreciate your introduction, and it's always a pleasure to see you. I remember when you were taking my class in 1978, a long time ago. It's really a pleasure to be able to speak at this conference. I wish I could be there in person, but I'll do the best I can. In the abstract that I sent, I gave some background. And the background has to do with a very simple fact, that ideas don't float in the air. They're not floating around here like that. Ideas are in your neural circuitry. And in your neural circuitry, it's not just in your brain, it goes throughout your body. And that's a very important thing to realize, that thought cannot be just in the brain. The reason for that is very simple. Imagine if you had just the brain without any contact to the body, without contact to the eyes, the ears, the arms, the legs, the skin. Imagine if you had no contact, whatever, to your body. What would that be like? Could you understand anything? What could you think about? The answer is you could not think about anything at all. There would be nothing to think about if you had nothing to see, nothing to touch, nothing to move with, nothing to hear. There would be nothing to think about. And that's a very important fact. You need to be able to, you think about things because your brain is connected to your body. And we will see as we go along that is crucial in understanding how a metaphor works. The other thing about this is that all ideas are in your neural circuitry, but mostly they're unconscious, and they have to be unconscious for a very simple reason, which is you do not have conscious access to your neural circuitry. You don't have any conscious way of linking up to your neural circuits. That is not a possibility. And the result is most thought is unconscious. So consciousness is a very small part of thought. Most thought, perhaps as much as 98%, a huge amount of thought is not conscious. Consciousness is very, very small, like the tip of the iceberg. So that's the first thing to realize, that most thought is unconscious, and it's automatic, and so on. That's very important to know as we start. Now, what I've been working on for 25 years with Srini Narayanan, my co-author, on the book on the neural mind, what I've been working on is this. I've been trying to understand how it is possible to get ideas and language out of neural circuitry. How does that work? And what we've done over the past 25 years is put together research in neuroscience, cognitive linguistics, cognitive science, neural computation, and body cognition. We've been putting together this research, and now we have almost a completed book on how this works. And the way it works is via modeling, computational modeling and other modeling, in which you understand not exactly the neurons that you have in your brain. Brains differ a lot, they change over time. But what the generalization over all the neural circuits has to be in order to account for everything in thought and language. That is a very difficult thing to do. So that is what we've been working on in this, and that's what I'm going to be talking about. I decided to limit the talk to 3 topics, which are primary metaphor, the neural embodiment of metaphor, and conceptual integrations. And I want to begin with primary metaphor. Primary metaphors are widespread around the world. They're very simple. They occur naturally. They arise naturally. And they're, things like you understand more is up and less is down. Quantity and verticality go together. So when you say, the stock market went up, or turn the radio down, you don't mean throw it against the ground. There's a metaphor in which quantity and verticality go together. That is in many, many languages around the world. Very common. Another important one is affection is warmth. You have someone is a warm person, a cold person, and so on. Why is that? And why is war out? Well, what we found out was the following. Think about it this way. Suppose you are held affectionately by your parents as a child. You're held affectionately, and you feel the bodily warmth. That is, there's a correlation between affection and warmth. In Morozov, every time you put water into a glass or a baby sees milk go into a bottle, there's a correlation between quantity, the amount you put in, and verticality. You pour more water into the glass every time the level goes up. You pile more books every time the level goes up. So there's no issue about that. They're correlated. But even if a child doesn't consciously notice it, the child's brain notices this. And that's an important thing. That is, your brain is always noticing things around you. And it's always activated by what you see, and unconsciously activated, automatically activated. Now, what happens is this. Let's take the metaphor that affection is warmth. We know that in the brain, temperature is registered in one part of the brain. Affection and trust are registered in a different part of the brain. Or with Morozov, quantity and verticality are registered in different parts of the brain. But what happens is you see them over and over again. If you're held affectionately by your parents, you feel it over and over again. The same thing happens when you have repeated correlations in your experience. So that is the basis of how primary metaphor occurs. But the question is, why should that happen? Why should it be that when you have two brain regions that are activated over and over again, that they form a primary metaphor? And how does it happen? What is the mechanism by which it happens? The mechanism is basically this. If you have two brain regions and they're activated over and over and over, okay? Every time they're activated, they get stronger. That is, the synapses get stronger. And when they're stronger, they're more likely to fire. So the stronger they get, the more they fire. And because every neuron is connected to 10,000 others, you get spreading activation. Activation spreads along existing pathways, and it goes out throughout the brain. And eventually, the shortest pathway is found. And when that shortest pathway is found, what happens is you form a circuit. A circuit is formed in your brain between those two things, say between quantity and verticality, warmed up, or between affection and warmth. Now, when that is formed, it goes in both directions. But at this point, a very important neural process takes place. It is called, it has a long name, spike timing dependent plasticity, and that's over there on your overhead. What that means is the following. A spike is a firing of a neuron. The one that fires first in its direction is strengthened in its direction, and if the other one fires second, if it's later, it's weakened. So the more one neuron fires first, the more it gets strengthened in one direction and weakened in the other, which results in an asymmetric flow of activation. Now, the question is, why should one get fired first? And notice, in that asymmetric flow, you have the difference between a source of a metaphor and a target of a metaphor. That is, the place where it is flowing toward is the target, the place it is flowing from is the source. So you get an asymmetric pattern of source to target. Now, why should that be? Why should some neurons fire first? And why should that give rise to a source? And the answer is that there's a direction in which you get more activation from one part of the brain than the other part of the brain. That one where you get more activation is going to be the source. That's where you're going to get more of the first firing. But that raises another question. Why should a neural circuit